Okay, so for tonight's lesson, or for tomorrow's lesson, I should say, we're going to go back and look a little bit at solving equations with inequalities. So these are just some very basic two-step equations. We want to solve for x here. So we treat this as this would just a regular old equation with the equal sign. We deal with this sign at the end. So here I need to isolate the x. So general rules are the reverse order of operations. Order of operations says you always do multiplication and division first and addition and subtraction second. Well, here we're going to work backwards to figure out what this value of x is. So working backwards, we're going to look for any addition and subtraction first, then take care of any multiplication and division. So here I see there's a plus 7. So I'm going to get rid of that first. And the inverse of plus 7 is subtracting 7. Or you can look at this as positive 7, and negative 7. And that will give you 0. And what you do to one side of the equation, you must balance and do to the other side. So we subtract 7 here, and that will give me 30. Okay, so now I'm left with this 2x over here. So we just bring the 2x down, and that is greater than our 30 here. And that is 2 times x. So again, the inverse of multiplication is division. So we'll divide by 2 and divide by 2. And so that will leave me with x is greater than 15. And so you have to look and say, what does that mean? Well, that means I can plug any value in for x as long as it's less than 15, and that will make this statement true. So if we go back and look up here, and let's just pick up a value that's less than 15. So let's pick an easy one, like 10. So if I were to plug in 10 for x, because 10 would fit this statement, or no, that would not fix that statement. What am I doing? It would say, see, here's a good, here's a good example of making an error, because I was going to say 10 is greater than 15, and that is clearly not true. I was thinking about this backwards. So, good thing I thought about that and corrected my mistake. X is greater than 15. So I have to pick a number greater than 15, so let's just pick 20. So if I pick that in, this statement will be true. 20 is greater than 15, right? I can also check it by plugging in up here for x. If I do 2 times, I'm going to pick 20 for my x, plus 7 is greater than 37. So 2 times 20 is 40. 40 plus 7 is 47. So that will give me 47 is greater than 37. So that checks. Let's go ahead and do what I was going to do in the first place and make an error. So if I said x could be 10, and I plugged in 2 times 10, plus 7 is greater than 37. Some issues with the mouse here, sorry. So it's a 10. So that'd be 20 plus 7. That would give me 27 is greater than 37. So that is a false statement, and clearly this cannot be x. Okay, so let's look at another example. Let's look down here. Here I have 23 minus 3x is less than 50. So again, I need to, this is multiplication, this is 3 times x, and this is a positive 23. And something we've been talking about a lot is you have to look to the left of the number to get its sign. So here, this is not 3x. This is negative 3x. Or if it makes you feel better, you could do change it, like you guys like to say. But to get rid of positive 23, I have to do its opposite, which would be negative 23. Or minus 23, which is the same thing. So I give me 0 there, and I can do negative or minus 23 here. And let's see, we'll do some borrowing. That'll give me 10 minus 3, which is 7. And then 4 minus 2, which is 2. Bring down the inequality here. And then I have negative 3x. Okay, so then that is a multiplication. Negative 3 times x, so opposite or inverse of negative, multiplying by negative 3. If I divide by negative 3 here, negative 3 divided by negative 3 is 1. So that would give me 1x, right? Now, when the rule is, hopefully you'll remember this, whenever you multiply or divide by a negative, the inequality sign flips directions. I know you can't read that, I'm going to move it. Okay, so this is kind of a rule that you should have learned that I thought I would remind you about tonight. So because I am dividing by a -3, this is going to change from less than to greater than. Okay, and then 27 divided by -3 would be a -9. So we have x is greater than -9. So that means I can plug in anything greater. If I plug in -8 here, this statement will be true. If I plug in 0, this statement will be true. Let's do that real quick. If I plug in 0 here, that becomes 0. And then we have 23 is less than 50. True statement. I know this is correct. Okay. If we hadn't flipped that around, then we would have a false statement. All right, so let's go up and look at this question real quick. Here we have 2.5x minus 14 is less than 42. Again, this is 2.5 times x. This is minus 14, so we want to get rid of the subtracting 14 first. And remember, we treat this as either minus 14 or you can treat it as a negative 14. And the inverse of negative 14 is a positive 14. So that gives you 0 here, and then we have positive 14 here. Okay, now some of you guys still need some help on your integer skills. So we have a negative and a positive. That means we need to subtract. So this becomes 3, and this becomes 8 and 2. And I have way more negative than positive, so the negative carries over to here. I have more negative, so when I take 14 away, I'll be left with negative 28. So still over here, I have a 2.5x is less than negative 28. So this is 2.5 times x. So I'm going to divide by 2.5 and divide by 2.5. Okay, so checking on the calculator, that is going to give me x is less than 70, negative 28 divided by 2.5. And again, when you have a negative and a positive, the negative carries over in multiplication division. Now, no, I did not flip the sign here because we only flip the sign when you multiply or divide by a negative. This answer just happened to be negative. I was not multiplying or dividing by a negative here. So again, we get that. Okay. And then this last one, you'll have one like this in class tomorrow. Again, we have 15 plus 1/2 times x is greater than 24. So again, this is a half times x, so I want to get rid of the 15. It's the opposite of, remember, we to the left, so this is positive 15, so we're going to go negative 15 here. And then we'll go minus or negative 15 here, however you want to look at it. And so then we'll borrow. And then 14 minus 5 is 9. And then we have our greater than sign. And then we have 1/2 x. And I put this one on here on purpose because you have one like this in your class problems today. And some of you guys forget about what to do with this. What we do, we can think about this in a couple of different ways. It's a half times x, so we could divide by half. Or the easier thing is to multiply by its reciprocal, because the reciprocal is the flip. So if I multiply by 2/1, the 2's cross off, the 1's cross off, and you're left with x. So we multiply by 2/1 or 2 here, and then that becomes x is greater than 18. Okay, so just a couple quick reminders about how to solve equations with inequalities there. So you're going to have some statements that look like this. This one asks you to draw an oval on the graph that represents the solution to the equation. Write the corresponding inequality statement. So here we have a hot air balloon at 1,400 feet before it begins its descent. So that tells me it's at 4,000 feet, so that's the y-intercept. It descends at a rate of 200 feet per minute. So again, that rate means slope, and it's descending, so it becomes negative, okay? So how many minutes have passed if the balloon is below 3,000 feet? So I already graphed this equation for you. So we would want to know where it is at 3,000 feet. So we draw this line. And we want to know how many minutes have passed if the balloon is below it. So here's the 3,000 foot line. We want to know below it. So we want to know all these minutes here are below that height, okay? So it starts at 5 and increases. So we have x is greater than 5, okay? So let's look at another example. This one says a bathtub's filled with 55 gallons of water. Again, that's the y-intercept. It drains at a rate of 5 gallons per minute. Again, rate means slope, and it's draining, so it means it's negative. So they went ahead and graphed this equation. F of x equals negative 5x, that's the slope, plus 55, the y-intercept. So here's our graph. See, again, it's at the y-intercept's at 55, and it's decreasing 5 and running 1. How many minutes have passed if the tub still has more than 20 gallons of water remaining in it? So first of all, here's my volume, right, my gallons. So I want to look at where 20 is. So I'm going to draw a line at 20 here. And then we want to look at time. So I'm going to draw a line down here. So let's see. 5, 6, 7, 8, 9, 10. So this is 7 minutes, right? Okay, so the question says, how many minutes have passed if the tub is still more than 20 gallons of water? Well, more would be 20 or above, right? So we're talking about this amount of water here, 20 or above. How many minutes have passed? So 7 have passed or less. So between 0 and 7 minutes, we'll have 20 gallons or more. So we should have x, which is time, because it's on the x-axis, is less than or equal to, because it includes that 7 minutes. So this is what you want to do on these problems. You want to find out where the amount is. You want to find out if they're talking about above that amount or below that amount, and make an equality for the time that's remaining. So go ahead and try this one on your own, and Mr. Cook and you will talk about it in class tomorrow. And may the force be with you. I will see you next week.